Alright, so here is the schedule that we emailed out before the end of the first semester. If you weren't able to download that or save it, you can pause the video and see what's going on here. The assignment numbers are all in a column here. The 3 just stands for the third quarter, so basically that's just assignment 1, assignment 2, assignment 3. Same kind of things that were going on last semester. So this week we would like you to try to get ahead. Remember that some of these assignments may change to ALEKS assignments, but if you do them for this first week, if you want to do these, that's fine. Or if you want to wait and see which ones are ALEKS assignments, we will update that as soon as possible. I will accept either one. So if you do the book work because you want to be ahead and you do that week, I'll accept those as book work. Okay. So you could pause that if you need to get anything off of there. Okay. So this should be for January 4th, 2021. Yay, 2021. Moving on from 2020. And let's get started here. So we're starting Chapter 8, Ratios and Proportions, page 457. And before we do that, let's get into the units of measurement real quick, in case you've forgotten some of them. So let's start with the metric system. And we have a mnemonic device, a memory device, to help us remember the metric system. So King, Henry, so King is kilo, the prefixes, right? King Henry, hecto. King Henry died, deca. Buy, that's the base. Drinking, chocolate, milk. Okay, King Henry died by drinking chocolate milk. So those are your units. Our bases are meters, usually we capital L for liters, and grams. We'll be mostly just using meters in the metric system for what we're doing. Okay, so if you are going converting something this way to the right, you are going to multiply by 10. And if you are moving something to the left, you're going to divide by 10. So that's a little review of the metric system there. Okay, so if A and B have the same units, then we can write the ratio as A to B, or A over B, or A colon B. Usually we'll use the ratio, the fraction. Okay, simplify the ratios. There's the King Henry died by drinking chocolate milk that I put up there. Okay, so what we want to do is convert those to the same units. So what we could do is we could, we want kilometers, so we have 1 kilometer is 1,000 meters. Kilometers to meters, 1, 2, 3. That's times 10 times 100 times 1,000. So 1 kilometer is 1,000 meters. And if you think about what this equals 1. Because a kilometer is 1,000 meters. So this ratio equals 1. Alright, so the kilometers are going to cancel out, the meters are going to cancel out. And now we can just deal with the numbers. So here 2 goes into 4 twice, and that's going to leave us with 2 over 1,000, and that will be 1 over 500. And because we converted them all to the same units, we don't need any units on that. Okay. Now here we have feet and yards. So if we think about that, so we want to kind of cancel out feet and yards. And so I would say How many feet are in a yard? It depends how many people are in the yard. How many feet are in a yard? In your yard. Okay, I think I told that joke first semester as well, so anyway. So normally in class I like to ask that and see if somebody actually remembers and somebody actually answers that, but usually somebody will. Well, okay, so mathematically 3 feet in 1 yard as far as measurement, as far as length goes. So remember that equals 1. 3 feet, 1 yard, that's the same, that's 1. Okay, so what that allows us to do is to equalize this here. So this is going to be 1 over 2, and then that's going to be 3 over 2. Yeah, we could leave the ratio like that. Okay, so let's think about this next one here. The perimeter of a triangle is 56 inches, so that's if we add up all the sides. The ratio of LM to MN is 5 to 4, so it's 5 to 4. Now these two angles are equal, the base angles are equal, that means it's an isosceles triangle, and if the base angles are equal, that means their opposite sides are equal also, so this is an isosceles triangle. Okay, so that's a review from first semester. So this is equal as well. Now if I add those up, that's only 14, that's not 56. That's because we were given this ratio, and the ratio would have been reduced. So what we do, this is a common thing, we're going to use this for a couple different things. I think we used this back in chapter 3 actually. I think we used this concept before, that we would put an X there, because that's what got reduced, right? It was 5 times something over 4 times, oops. I love whiteout, so great. Alright, so it was 5 times something over 4 times something, but we were able to reduce it just like we did here, and they reduced it to 5 over 4. But really it was 5x over 4x, and so that's how we can come over here and put x's on all those. And now if we add all those together, that's going to be 14x equals 56, equals the perimeter before it got reduced. So if we divide both sides by 14, or divide the whole thing by 14, what do we get there? Well, we could divide both of those by 7. That would be 8 over 2. And that's 4. So we find out that x equals 4. The question asks us to find the lengths of the sides. And so if we plug in 4, we're going to get that LM and LN equal 4 times 5 is 20. So that's going to be 20, and it says indicate units of measure. So if you take an AP math class, it'll say indicate units of measure if you have to have the units on there. So that's going to be 20 inches, and then MN is the base, and that's going to be 4 times 4, so that's going to be 16 inches. Okay, now let's think about that for a moment. If we go back and think about the sides here, 20 over 16, and if we think about that, that's 5 times 4 and 4 times 4, and those canceled out, and that's why we had a ratio of 5/4 up here. And so the x was 4, and that's what canceled, that's what reduced to 1. Okay. So moving right along, example 3 here, the measures of the angles of a triangle are in the extended ratio of 3 to 4 to 8. Find the measures of the angles and classify the triangle. So maybe, I don't know if we did this last semester or not, but anyway, if you're talking about the 3 angles of a triangle, okay, so 3 angles of a triangle, then what should come to mind is 180. And so the angles are supposed to add up to 180. Now, again, it's the same thing as the sides up here. So they reduced. The angles reduced down to 3 to 4 to 8. So we're going to do the same thing we did up there. We're going to put 3x plus 4x plus 8x. equals 180. Okay? Because the x was divided out to reduce the ratio to that. So if we add those together, we get 15x. If we divide both sides by 15, we can do that over here if we need to. 180 divided by 15, that's 1, and 30, and that's 2. So x equals 12. And if we go back, the question, I'm sure, said find the measures of the angles, actually, not just x. So that's going to be 3 times 12 is 36. 4 times 12 is 48. And then we have 8 times 12, that's 80 plus 16, which is 96. So that's that. Now all the angles are different, so that means it's scalene, and the biggest angle is obtuse, so that means it's obtuse. Alright, so a proportion is when we equate two ratios, put two ratios together. Now, if you think about this ratio right here, so the ratio is A to B is equal to C to D. Okay, so what I want to point out here is that the mean is the average, is the middle. So those are called the means, B and C. And the ones on the outside are called the extremes. So that would be A and D. And if you think about what extreme means, if we say a person is extreme, that means they're on the outside of what's normal. And normal's not always good, but that's a different discussion. Anyway, so extreme sports, they don't really, probably don't seem extreme anymore, but back in the day it was like skateboarding and snowboarding and BMX biking and stuff like that was the stuff that was outside the normal situation. Okay, so that vocabulary might come in handy to remember that the means are these two and the extremes are these two. And setting it up this way might help you remember that, which ones are in the middle, which ones are not. Okay, so the cross product property says that if A over B equals C over D, then if we cross multiply, those things should be equal to each other. Okay. And that's it. Alright, the reciprocal property should make sense. So if we have these two fractions that are equal, and then we flip them over, they'll still be equal. So hopefully, so yeah, that kind of makes sense. We could make up an example and look at it. So think about 3 over 6 equals 1/2. Yeah, because 1/2 is the reduced version of 3 over 6. Now if we take the reciprocal of that, we'd have 6 over 3 and we'd have 2 over 1, and those are both still equal to each other. Those are both 2. Okay, so, whoa, I don't know if that light helps or not, but let's try it out. So, another way to look at this is to actually cross multiply these. So if we cross multiply this, this is A times D, and this is B times C. And if we cross multiply these two, we get B times C equals A times D. And that's just that flipped over, so that should make sense. Okay? Now, let's see what we want to do here. So normally, when we're looking at a triangle, we use a lowercase letter to represent the sides. That would be lowercase t, this would be lowercase u, this would be lowercase v, This would be lowercase s, this would be lowercase r, that'd be lowercase q. Alright? So, it says the ratios of QRS to VTU are 3 to 2. So you want to think about going this way, it's 3 to 2. And the ratio then coming this way would be 2 to 3. Okay. So, it says find the unknown lengths. So, if we look at, let's go, R is right here. So we have R over, so it says, so keep the variables, in the numerator. Okay, so I want to find R, so I'm going to put R in the numerator. So R goes with this side over here. If you think about R is QS, and that's going to go with VU, which is right there. So R over 2 equals, and that's 3 over 2. Okay. So clearly R equals 3 centimeters. So we figured out one of our sides. Now let's go with this SR. SR matches up with TU. So TU, which is V. So now we're trying to find V. So V over 18. Now, because we're comparing V, remember is the smaller triangle, so that's going to be the 2, and the bigger triangle is going to be the 3. So the 18 was from the bigger triangle, 3 is the bigger triangle, so hopefully that kind of makes sense. Alright, so here, both sides we're going to multiply by 18. Now on this side, we could have multiplied both sides by 2, and those 2's would cancel out, and we would get 3. But it was obvious because it was 2. But that's another way to make it so it's all the same. Multiply both sides by the denominator. So we're going to multiply both sides by 18. That's going to cancel out here. This is going to be 6 times 2. So 6 times 2 is 12 centimeters. Okay, so we've got R and V so far. Now, now that we have two sides in the triangle, we don't have either hypotenuse. So what we can do now is use the Pythagorean theorem. So we know that this side is 2, and we know that V is 12. So if we do that, using 2 and 12, we'll have 2 squared plus 12 squared equals U squared. So that's going to be 4 plus 144. Now I have a trick for this. It might not be helpful for some of us, but a lot of you are just going to multiply that or add that together and get 148, and then you could take the square root of both sides and you could start to reduce 148. But what we could also do here is we could factor out a 4. 4 goes into both of those. So 4 goes into 4 once, and 4 goes into this 36 times. And then we're about to take the square root of both sides. And now I can simplify that much more easily. The square root of 4 is 2, and the square root of 37 is 6 point something, which is not going to reduce for us. So U is 2 root 37. And then our last step would be to set up a proportion with U and S. And I said to put the variable on top, so that's going to be S over 2 root 37 equals, and that's the bigger one over the smaller one, so that's 3 over 2. And if you look at that, hopefully it's kind of obvious to you that S is going to need to be 3 root 37, because the root 37s will cancel and we'll be left with 3 over 2. Okay. A little bit tricky there, but this is honors geometry. So, all right, we're halfway done. And we want to solve a proportion here, so the easiest way probably to do that would just be to cross multiply. So if we cross multiply here, we're going to get 9 times x equals 6 times 14. So we're going to give you some advice here. Notice how I did not multiply that out. I left it because what we're about to do next is we're about to divide by 9, and things may cancel out. So instead of multiplying this together right away, we leave it and we reduce here. So 3 goes into there twice, and 3 goes into here 3 times. And if we multiply, 2 times 14 is 28, and that's 28 over 3. And as long as it's not a word problem, we'll just leave it like that. Okay, now over here, we're going to cross multiply again. So that's going to be 10 times w minus 5 equals 4 times w. So if you distribute that, that's going to be 10w minus, you could leave it as 5 times 10, or you could multiply it out. It's up to you. That one's pretty straightforward, times 10, so 4w. So we can subtract 4w from both sides. And 10w minus 4w is 6w, and we can add this to the other side, so that's going to be 5 times 10. Now we're going to divide by 6, and we can reduce right here. So 2 goes into there 5 times, 2 goes into there 3 times, so that's going to be 25 over 3. 25 over 3. So just a coincidence that those are both over 3. Hopefully you're pausing. I forgot to mention that, but we did that all first semester, so you want to pause, try the problem yourself first. So, we're going to have these word problems in the first 3 lessons, I think, and so the way to do that is we have an actual building, and we have a picture of the building, because these are in inches, so let's see. So we have, what are we trying to find? We're trying to find out how tall the actual building is. And we have height, tall, and wide. Okay? So, tall and wide, and we're trying to find out how tall the actual building is. So let's do the actual and then the drawing over there. Or the picture, whatever. Okay, so how tall is the building? So I'm going to use T. Some people use X all the time, and if we have word problems that have a couple different variables, it's kind of helpful to use a letter that goes with it. So T for tall, and then that's going to be equal to how, so that's how tall is the actual building. How wide is the actual building? That's 26 1/4. But it's better to switch that to a fraction. So that would be an improper fraction instead of a mixed number. So that's going to be 104 plus 1 is 105. So it's going to be 105 over 4. Okay? And then we're going to have that over the drawing. So how tall is the drawing? The drawing is 2 3/4, which is 11 over 4. And then how wide is the drawing? That's going to be 15 over 8. Okay, so use that to help you because the next 2 lessons are going to have word problems similar to this. So use this kind of chart to fill those things in. So now we have a complex fraction like we did with midpoints way back when. Complex. Remember, a complex fraction is just a fraction that has fractions in it. So we want to get rid of the common denominator. So the common denominator is 8. So we're going to multiply this by 8 over 8 and 8 over 8. That's going to cancel those. And then what's that going to leave us with? Right here it's going to leave us with 8t. And then 8 over 4 is 2 times 11 is 22. So that's going to be over 22. And this is going to be 2 times 105, which is 210. And that cancels out. That's just going to be 15. All right. So if we could reduce some here. So 2 goes into here 4 times, and 2 goes into here 11 times, and 5 goes into here 3 times, and 5 goes into here 42 times. Okay, so if we multiply both sides by 11, we're going to have 4t equals 42 times 11 over 3. And then we can multiply or divide both sides by 4 or multiply by 1/4. So that's going to give us a 4 there, and that's going to reduce to 21 over 2. It's pretty unpleasant. So the actual height of the building is going to be 21 times 11 over, 3 and 21. 3 goes into there 7 times. That's good. So 77 over 2, which is, now this is a word problem, so we would want to change that. It's a little bit awkward to leave it like that. So that would be 38.5 feet. Now this last one is a little bit on the tricky side. So it says the ratio of cats to dogs is 3 to 2, and the ratio of cats to rabbits. So the first thing you should realize there is that they're both being compared to cats. So that seems kind of important, comparing to cats. So if we kind of start with cats here like this, and so it says 3 cats to 2 dogs like that, and then here it's 18 cats to 1 rabbit like that. Then when we want to compare rabbits or dogs to rabbits, so let's take this ratio and think about that. So that's 3 to 18 and 2 to what? So I said put that, so let's put dogs. So dogs over 2 equals 18 over 3 to keep these two proportions the same. So we're just kind of, so if we multiply both sides, that's 6. 18 divided by 3 is 6. Multiply both sides by 2, you get 12. So if there's 2 dogs for every 3 cats, there's 12 dogs for every 18 cats. And now these are both being compared to 18, so we can compare them to each other. It said dogs to rabbits, though, so we need to do 12 to 1. Dogs first. I probably did that a little bit fast, but again, hopefully, you pause it, pause that video, and do that. Okay, so this is a review, graphing lines, and so we can talk about what kind of line do we have there. So this is standard form, and we usually use standard form to get the x and the y intercept. So we let x equal 0, divide both sides by 8, that would be 1, and then we let y be 0, and then divide by 4, and we get x equals 2. So 0, 1 is up here, and 2, 0 is right there. So now we can see that the slope is negative 1/2. So we can continue that across here and this way. Now we want to go all the way across like that, and then we want to go to the end. So go way over here and line it up with way over here. Alright. Moving to the next one, this is a vertical line, and that's x always equals -4. So here's x and here's -4. So that line goes up and down. We call somebody's vertical how high they can jump. So there's a vertical line. And the next line is horizontal. Alright, so that one is y equals 7. So y always equals 7. And our last line, that is in last one down there. That is slope-intercept form. Slope-intercept. So y equals mx plus b, where that's the y-intercept, and then the slope is -2. So that means down 2 to the right 1. And now I can see the other line, so I don't really need to keep going all the way across the graph there. So there we go. And then if we look at the quadrilateral, that is in between those 4 lines. I don't know if you got it immediately or not, but so what helps sometimes is to change your point of view. A lot of times we get stuck in one point of view and we need to change that. And so maybe if you turn it around, move it, maybe right here it will come into view for you and you can say, oh yeah, that's a kite. Okay, so classify the quadrilateral. It's a kite. Area, you're going to put units squared and units on that immediately. And now we need to figure some stuff out here. So area, there's a couple different ways you could do that. You could cut it up into pieces. That might be the easiest. So if you look right here, there's a trapezoid and a triangle. So the area of a trapezoid is the average of the bases. So the top base is 4, and the bottom base is 6, times the height, which is 4. So that's 10, and half of 4 is 2, so that's 20. Okay, now here we have a triangle, and we have the base and the height. So the base is 1, 2, 3, 4, 5, 6, and the height would be, we would actually draw it over here. That's going to be 4. So it's 1/2 of 4 times 6. So that's 2 times 6 is 12. So the area is 32 units squared. Now there are other ways to do that. We could look at this whole square here instead, and we could find the area of that square and then subtract off those 2 triangles. Okay, so I don't know if we want to do that. It'd be confusing a little bit. There's a square there, and that would be 8 squared minus these 2 white triangles over here. So that's 1/2 of 4 times 8, but there are 2 of them. So the 2 actually cancels out the 1/2, so you're going to get 64 minus 32, which is 32. Anyway, let's get the perimeter. So that's going to be 4 just by counting, and this is going to be 4 by counting also. And so then we need to find the length of that using the Pythagorean theorem and double it. So that's 4 and 8. So we're going to have 4 squared plus 8 squared equals c squared. So that's going to be 16 plus 64, which is 80, which is 16 times 5, which is 4 root 5. So that's going to be 4 root 5, which means that's going to be 4 root 5 also. So 4 plus 4 is 8, and 4 root 5 plus 4 root 5 is 8 root 5. Now, there's actually a third way to do the area of a kite. The area of a kite is 1/2 the product of the diagonals, d1 times d2. And if you look at that triangle, that's a right isosceles triangle, 4 and 4. And so the hypotenuse of a right isosceles triangle is always the square root of 2 times the side. So that would be 4 root 2. So if we did that, that would be 4 root 2. And the longer diagonal, that's 8 and 8, that would be 8 root 2. So root 2 times root 2 is 2. And 2 times 1/2, that cancels out. And 8 times 4 is 32. So there are 3 ways to find the area of that kite. Alright, last one here. Let's wrap this up. So parents agree to buy her tickets, 10 hours a week helping around the house for 6 weeks, averages 10 hours. First 5 weeks was right there. So if you add those together, it's going to be 19 plus 19 plus 10. So that's going to be 48. So the question is, how many hours does she have to work the last week? So you've got 48 hours plus the hours from the last week. And there were 6 weeks total, and they have to average 10. So how do you get an average? You add up the total and you divide it by how many you have. And they already told us the average is supposed to be 10. I am not pausing at all to let you think about that, but you do have a pause button, and you should be using it. Okay, so multiply both sides by 6. So you're going to get that, and subtract 48 from both sides. So she needs to work 12 hours the last week. And that wraps up our first lesson of 2021. Have a great day.